Passive earth pressure is a type of soil pressure exerted by soil against a retaining structure such as a wall or foundation. It occurs when the soil pushes against the structure in response to the external force like a load or excavation. This pressure is at its maximum when the soil is prevented from moving outward, and it diminishes as the structure moves away from the soil. Understanding passive earth pressure is crucial in designing stable retaining walls and other geotechnical structures. Hello and welcome back to the Master Civil Engineering. And in this video, we will learn that how to find the passive earth pressure distribution across a layered soil. I have been given a question which states that we have a 3-layered backfill behind a 9-meter high retaining wall with a smooth vertical back. We have to draw the passive earth pressure distribution, determine the Rankine's passive force per unit length of the wall, and the location of the resultant force. You can see the 3-layered soil in which the surcharge of 15 kilopascal is applied at the top of the soil and water table is at the top of the layer second. So first thing which you will do is that you will first find the passive earth pressure coefficients for each layer. So for layer first, which is C is equal to 0 soil, the value of passive earth pressure, this is 1 plus sine phi dash divided by 1 minus sine phi dash. The value of phi dash for layer first is set 30, so it will be 1 plus sine of 30 divided by 1 minus sine of 30, which is 3. For layer second, this is a C phi soil. The value of passive earth pressure coefficient, this will be 1 plus sine of 25 divided by 1 minus sine of 25, which is equal to 2.46. For layer 3, this is phi u is equal to 0 soil. So passive earth pressure coefficient, this will be 1 plus sine of 0 divided by 1 minus sine of 0, which is 1. After finding the passive earth pressure coefficients for each layer, next step is that you will, before finding the passive earth pressure at each point, you will first find the effective vertical stress at each point. So if I take the layer first at its top, that at z is equal to 0, the value of effective vertical stress at this point will be gamma z plus q. So gamma is the unit weight for layer first, which is 20 kilonewton per meter cube. So it will be 20 into 0 plus 15, which is 15 kilopascal. After that, the passive earth pressure at this point is simply effective vertical stress multiplied by the passive earth pressure coefficient. So it is 3 into 15, which is 45 kilopascal. This is the value of passive earth pressure at the top of the layer first. Similarly, at z is equal to 3 meters, the value of effective vertical stress, this is equal to 20 into 3 plus 15, which is 75 kilopascal. The value of passive earth pressure, this will be 3 into 75, which is equal to 225 kilopascal. Now in layer second, at z is equal to 3, the value of effective vertical stress, this will not change. Okay, so it will be same, which is at the bottom of the layer first. This will be equal to at the top of the layer second. So this is again equal to 75 kilopascal. Since this is a C phi soil, so value of passive earth pressure for this soil, this is equal to Kp2 into Pv plus 2c dash under root of Kp2 plus gamma Wz. The value of Kp2 or passive earth pressure coefficient for layer 2, this is 2.46. Effective vertical stress at this point is 75, so it will be 2.46 into 75 plus 2 into 20, since the value of C dash for this layer is 20 kilopascal, into under root of 2.46 plus 9.81 into 0. Since the water table is at the top of the layer second, so its effect will be added to the passive pressure. At the top, it is depth is 0, so that's why we have used z is equal to 0 for the water pressure at the top of the layer second. So this gives me the value of passive earth pressure at the top of the layer second equal to 47.24 kilopascal. Now at the bottom of the layer second, or z is equal to 6 meters, the value of effective vertical stress, this will be equal to 20 into 3 plus the we have to use the submerged weight for the layer second, so it will be 18 minus 9.81 into 3 plus 15, which is 99.57 kilopascal. Then the value of passive earth pressure, this will be equal to 2.46 into 99.57 plus 2 into 20 under root of 2.46 plus 9.81 into 3, since the depth of water table at the bottom of the layer second is 3 meters. So this gives me the value of passive earth pressure at the bottom of the layer second equal to 337.11 kilopascal. Now in the layer third, again that is at z is equal to 6 meter, the value of effective vertical stress at the top of the layer third will be same as at the bottom of the layer second, which is equal to 99.57 kilopascal. Since this is phi u is equal to 0 soil, so the value of passive pressure will be equal to kp3 into pv plus 2c dash under root of kp3 plus gamma w into h2. The value of passive earth pressure for layer third, this is 1, so it will be 1 into 99.57 plus 2 into 35, since the value of c dash in this layer is 35 kilopascal, into under root of 1 plus 9.81 into 3, because the depth of water table at the top of the layer third is 3 meters. So this gives me the value of passive earth pressure at this point equal to 199 kilopascal. At the bottom of the layer third, or z is equal to 9 meter, the value of effective vertical stress, this is 20 into 3 plus 18 minus 9.81 into 3 plus 16 minus 9.81 into 3 plus 15, which is equal to 118.14 kilopascal. The value of passive earth pressure at this point, this will be equal to 1 into 118.14 plus 2 into 35 into under root 1 plus 9.81 into 6, since the depth of the water table at the bottom of the layer third, it will be 6 meters. So this gives me the value of passive earth pressure at this point equal to 247 kilopascal. After finding the passive earth pressure at each point, you can now draw the passive earth pressure distribution for this soil. So first you will draw a vertical line, divide it into the 3 parts, that is 0, 3 meter, 6 meter, 9 meter. At z is equal to 0, passive earth pressure is 45 kilopascal. At z is equal to 3, passive earth pressure is 225 kilopascal. At z is equal to 3 meters in layer second, the value of passive earth pressure is 247.24 kilopascal. At z is equal to 6 meter in layer second, the value of passive earth pressure is 337.11 kilopascal. At z is equal to 6 meter in layer third, the value of passive earth pressure is 199 kilopascal. And at z is equal to 9 meter, the value of passive earth pressure is 247 kilopascal. So this gives us the passive earth pressure distribution for this soil. After that, to find the total force, you will find the area of this diagram. So you can divide it into the simple geometric figures like the rectangle and triangle. So for I have divided it into the 6 geometrical figures. Okay, so for first figure, that is F1, force is 45 into 3, which is 135 kilonewton. For F2, which is a triangle, so it will be half of 225 minus 45 into 3, which is 270 kilonewton. For F3, which is again a rectangle, so it will be 247.24 into 3, which is 741.72 kilonewton. For F4, this is half of 337.11 minus 247.24 into 3, which is 134.81 kilonewton. F5, this is a rectangle, so it will be again 199 into 3. This is equal to 597 kilonewton. F6, this is a triangle, so it will be 1/2 of 247 minus 199 into 3. This is 72 kilonewton. Total passive earth pressure force, this is the sum of these values, so it will be equal to F1 plus F2 plus F3 plus F4 plus F5 plus F6, which is equal to 1950.53 kilonewton. This is a total passive earth pressure force on the retaining wall. To find its location, you will take the moment of all the force about the bottom of the wall. Okay, so for first force, it is acting from the bottom at a distance of 3 by 2 plus 6, you can say 7.5 meter. Second force, this is acting from the bottom at 3 by 3 plus 6 or 7 meters. Third force, this is acting from bottom at 3 by 2 plus 3 or you can say 4.5 meters. Fourth force, this is acting from bottom at 3 by 3 plus 3, which is 4 meters. Fifth force, this is acting from bottom at 3 by 2, which is 1.5 meters. And last force, F6, this is acting from bottom at a distance of 3 by 3, which is 1 meter. Taking moments about the bottom and dividing it by the total force, which is 1950.53, we get the value of the centroid, or you can say the location of the total force, equal to 3.97 meter from the bottom of the wall. Okay, so this is the location of the total passive earth pressure force from the bottom of the wall. This video showed you step-by-step procedure to find the first find the passive earth pressure distribution across this layered soil, then find the total passive earth pressure, and finally find its location from the bottom of the wall. I hope you guys enjoyed the video and learned something new. If you find my videos helpful, please subscribe to my channel and share this video with your friends. Thanks for watching and stay tuned.